ACS comm error. Should connect automatically in a second here. We're going to switch these to none. So if you highlight everything, and then I can go to change values, it gives me, so I can select a bunch of things here. We'll set to none, and then it updates everything. It's probably trying to communicate to a printer that doesn't exist. Great. What does it say over there? Does it say
Start
external?
ready. Yes. Doesn't say, yeah, it's external.
So it's still in a comm error. Comm error. Okay, so that's communicating. I think it was trying to send things to a plotter that didn't exist. So now that our printer and plotter are set to none, this should be more successful. Since we already have row 1 done, we should be able to go through 2 and then 3. This, I guess. Does this cast need to go to a few mode or anything?
No, just second first time.
It's only 1%. I just, because this regulator was connected to the previous model, so we should just let it purge a bit. And we'll purge the syringe too. So I like to use Graphic Method Editor to look at my processing methods. So these integrations look pretty good. That's oxygen right there. We want to use the processing method, which is loaded to the GC. Okay. I can't edit this as in read only right now because it's loaded to the GC, but you can see that the baselines look a lot better. What we will need to do is adjust carbon dioxide. Again, remember
Yeah, don't adjust.
that's CO2 right there.
Oh,
This inflection right here is going to be the CO2 peak.
that's a CO2 detected by the
TCD. TCD.
TCD.
Yeah, it's very low. The attenuation's not turned up. So there's a ethylene, ethane. There's no acetylene. Tiny bit of oxygen, probably because
No.
the syringe isn't purged and everything. Bunch of nitrogen, methane, carbon monoxide. We update the retention times too.
We don't see carbon dioxide.
Carbon dioxide.
Is very small. This is it's right there. This is carbon dioxide. This is a case where if you're just running 0.1% CO2, you can send that to the methanizer and you'll have a peak that looks like this on the methanizer. But we're bypassing that. We're just going off the TCD, and it's not as sensitive. And also, we have room to adjust the attenuation of the TCD to make that peak, your hydrogen peak, bigger.
So larger amount will lead into the peak shift to the left.
Yes,
Or
it will.
right.
It will. It for CO2,
Uh-huh.
it tends to shift to the left
Oh, okay.
on that type of column, that pack column. Whereas the other components will tend to shift right. It is peculiar, but I don't know the ins and outs of it all. These guys are on a different column, different chemistries. In general, though, yes, more amounts, which greater amount tends to right shift peaks. Depends on shape too. If you start with capillary column, it's different than a packed column. Like if you overload a plot column, capillary columns, you overload, we always call it shark fitting. So you get, the peak comes up and then tails down. So on a capillary column, overloading would look like this, and then a flat. More so, I guess it would be like, it would come up and then tail out like this. On a plot column, so this is wall-coated open tubular. On a plot column, porous layer open tubular, you get a fronting that's flat and then tails down. Oh, I have these backwards. What am I talking about? Backwards. Wall-coated open tubular columns,
Like very vertically.
and then it comes down, and then plot columns, it's the opposite, where it goes up and then comes down. So this looks more like a shark fin than a plot column. Okay, let's see what we're doing here. So do we have result files? Oops. So we do have a result file for that first chromatogram. Okay. That's probably what was giving us problems. Yeah. So it wouldn't process the data. If we go to our file explorer and look at that result file, See how it says 0? That means that it wasn't processed properly. It should have it'd probably be about a 15 kilobyte file. So when I try to open it, it crashes because there's no data assigned to it. Something happened, which is why the system hung up when it was trying to process that file.
So it didn't say the first time data?
Didn't save the result data. The raw file's there.
Okay.
We can right here. We can reprocess
Is
that.
it the process method issue or?
Yeah, fine. Okay. It's still acquiring.
Oh, Superman.
Because we can, if we go into data review and our results, our raw files, we have it right here. Right here. Not sure. One thing I don't think this would affect it, but if we go to our processing method, which is processing this one. It's set to dual channel. Maybe it needs to be set to B.
It's a peak at 2.5. That's carbon dioxide.
Yeah, so it's
1% now.
a little bit. So we've adjusted this valve timing because when we run a lot of carbon dioxide at like 60%, it elutes over here. It starts to come out like big here and then tails down. And so I've set this timing a little bit earlier than if you're running a low amount, which is a little more rate shifted, so that what's happening right now is we're clipping a small portion of that tail, and this CO2 is going to the methanizer.
Oh,
It's a small portion, but we had to switch the valve timing earlier. Excuse me, because this peak in a matrix of 90% CO2 would start to elute with ethylene, and it was causing problems.
yeah, as long as it's not overlap with ethylene, then it should be fine at this condition.
That's why we have it shifted that way. Yeah.
But do you want to quantitate the CO2 trap?
They don't.
They don't. Okay. Because that's your matrix, right?
Oh, yeah.
For me, yes. That's
Yeah, but
What is your matrix? Generally CO2 or?
it's normally air with higher concentration of CO2 at 20%.